Every morning, before a restaurant kitchen even opens its doors, someone has to do this. Check the shelves, count items, compare to minimum levels, write 3 separate emails to 3 separate suppliers by hand every single day. That's about 40 minutes of skilled time spent on a task that has clear inputs, a defined output, and deterministic success criteria. In other words, it's a perfect job for an AI agent. Let me make this concrete. 40 minutes a day across 300 service days is over 150 hours a year of a skilled manager's time on data entry. And the failure mode compound. A missed item on the restock list means you ran out of Roma tomatoes mid-dinner service. A vague email, please send some olive oil, triggers a phone call from the supplier that delays delivery by a day. No tracking of what's already been ordered means you accidentally send duplicate requests. These aren't edge cases. These are the daily reality of a restaurant operations. The question isn't can AI help here? It's what's the right way to build it with agents. A single LLM prompt can draft a passable email, but it can't audit inventory and draft a supply email and check its own work reliably in a structured way every time. That's exactly where a multi-agent architecture wins. Each agent has one job and one job only. The auditor checks stock levels using a live tool call. The procurement agent drafts the email using those results. And the evaluator acts as a quality gate. It scores the draft against 3 hard criteria. Are all the items mentioned? Does each one have an exact quantity? And is there a concrete delivery date? If the email fails, the evaluator sends targeted feedback back to procurement, which rewrites it. The loop runs up to 3 times and it keeps going until the email passes. No human involved, no manual checking, the system critiques itself. Here's how all the pieces connect. The manager uses a React Web dashboard. They see the live inventory table, update the stock count, and that's it. That put request hit the Fast API backend. The backend checks, is this item now below its minimum threshold? If yes, it groups all the low stock items for that supplier together, checks the database to exclude anything already in a sent draft, and fires the ADK pipeline. The pipeline runs the 3 agents in sequence. The auditor calls the MCP server over stdio. The MCP server queries SQLite, validates every record through Pydantic, and returns clean inventory JSON. The auditor produces a shortage report, the procurement draft an email, evaluator grades it. The result lands back in the database as a draft. The manager sees it in the dashboard, reviews it, edits if needed, and sends it directly to the supplier via Gmail, one click. Instead of the current web dashboard, we can integrate the whole backend into an existing POS system as well. Let me show you this end to end. Here's the inventory dashboard. You can see all the items, their current stock, minimum thresholds, and which supplier they come from. I'm going to drop Roma tomatoes below its minimum threshold. Watch what happens. The backend detected the low stock event, grouped it with garlic, another item from the same supplier, and automatically fired the agent pipeline. No manual run command, no terminal, just a stock update. Behind the scenes, the auditor is calling the MCP tool right now, producing a shortage report. Procurement is drafting the email, evaluator is checking it. And there it is, the draft landed, one combined email for both Roma tomatoes and garlic, with exact quantities and a delivery date. And now I'll send it. Real Gmail, real supply email, one click. Done. The database has marked both items as requested. If I update stock again before the order arrives, the system knows not to send a duplicate. Here's the tech stack. 3 LLM agent instances from Google ADK. Auditor, procurement, evaluator. Each with its own runner and isolated session, so conversation history never bleeds between them. The inventory tool is served by a fast MCP server over stdio. The ADK MCP toolset discovers it dynamically at runtime via the MCP handshake. No hard-coded function imports. The backend is Fast API with SQL Alchemy to SQLite. The frontend is React 19 with Vite. Deliberately thin, just fetches API state and renders it. Secrets live exclusively in .env, loaded by python.env, validated at startup. The Docker file is multi-stage with an unroot runtime user. No API keys packed into layers. A single make Docker up runs the whole thing. The full source is on GitHub with a detailed README, architecture diagrams, setup instructions, and sample output. One stock update, zero manual procurement. There's what multi-agent systems can do for the business operations, not as a demo, but as a real tool that saves real time every single day. Thanks for watching. The full project is linked below.